Good morning, everyone, and thanks for joining us for today's webinar, Soil Sampling for Effective Use of Phosphorus, Potassium, and Lime with Precision Agriculture Technologies. My name is Julia Froik, and I am the project coordinator here at the Partnership for Ag Resource Management, and will be hosting the webinar this morning. We are joined today by my colleague, Dr. Thomas Green, president and co-founder of the IPM Institute, who will provide a brief introduction. I'm also pleased to welcome our guest speaker, Dr. Antonio Mallarino, Professor of Agronomy and Nutrient Management Research at Iowa State University. Before we begin, I will go over some brief logistics. Please make use of the question box on your screen to type questions for Dr. Mallarino during his presentation. I will moderate the questions during the last 10 minutes of the webinar after the presentation. Also, this webinar is being recorded and will be available later on partnershipfarm.org. By attending today's webinar, you are eligible for 1.5 CCA continuing education units, 1 for nutrient management, and 0.5 for soil and water management. You must be present for the entire webinar to receive those points. If you are watching this webinar live, you'll receive an email in the next few days with the webinar recording, a webinar evaluation, and a link to submit your CCA credentials to earn the 1.5 CCA CEUs, if you have not already done so when you initially registered. This form will also need to be filled out if you are attending the webinar over the phone. Please make a big note that the credits often take a few weeks to appear in your account. If it has been more than 2 to 3 weeks, please contact my email at julia@partnershipfarm.org. If you are watching this on demand at a later date, please be sure to watch the entire presentation through the GoToWebinar platform and not YouTube to receive credit. A link to register will be provided in the text below the YouTube video recording and on our website, or it will be emailed to you if you have already registered for this webinar. You are provided instructions at the end of this presentation to submit your credentials. And now, with the logistics taken care of, I will turn it over to Tom.
Thanks, Julia, and thanks everybody for joining us today. Looks like we've got about 100 people on the line. So the Partnership for Ag Resource Management is one of the many projects at our nonprofit IPM Institute, each focused on using the power of the marketplace to improve sustainability. Our team of 24 is currently working to increase adoption of best practice and improve outcomes in health, environment, and economics, all key elements of sustainability. We also work with pest control companies, hospitals, schools, and other facilities in communities, and of course with food companies and farmers around the world to improve practices and performance and to communicate those benefits to buyers and the public. We also write regularly for Crops and Soils magazine, and we'll have an article in the upcoming edition on 2 new corn foliar diseases. So next slide. So our objectives with our Partnership for Ag Resource Management are to identify revenue opportunities for ag retailers that help keep our valuable ag resources on cropland, help promote those products and services, track sales through annual surveys, and estimate reductions in losses of nutrients and other inputs that result from these sales. And then we report these sales data back to participating ag retailers for the location and also for the state association and provide regional averages as well. We work with ag retailers and industry associations to publicize these great accomplishments through press releases and articles, and our survey results were reported to the Ohio legislature this spring. It's very important to get this positive news out to address misperceptions the public has about agriculture. We're all aware of the water quality changes that we face, from the record-breaking algal blooms in western Lake Erie Basin to the larger than ever hypoxic zones in the Gulf of Mexico. Next slide. We also know that agriculture can make a difference. There are many signs of improvement in the Chesapeake Bay, for example, after a couple decades of focused efforts to identify and implement solutions, including cover crops. So this graph in the upper left shows the record algal blooms that we've experienced over the past 10 years in the Western Lake Erie Basin, and then some shots from that water body. And then we can see the hypoxic zone in the Gulf of Mexico, which has been about the size of the state of New Jersey in recent years. As I'm speaking to you, I'm looking out on our Lake Mendota in Madison, which is pea soup green from phosphorus coming from upstream. And we've already had a number of beach closings here in Madison due to phosphorus. Next slide. So we have these challenges, and we also have some great opportunities with products and services which can keep inputs on cropland and out of waterways. Here's a list of some of those for phosphorus retention and use efficiency, along with some very rough average reductions based on published studies. There's lots of variability in the published numbers based on soil type, slope, proximity to surface water, and other factors, but these rough averages that we've created from those published studies give us a sense of where we can likely make a difference. So cover crops, soil testing, grid or zone sampling, variable rate application, custom application are all revenue generating opportunities to reduce phosphorus losses. Ag retailers can also let farmers know when a broadcast application's been made so they can get out there and get the application covered. We can avoid application before a heavy rain event, abide by setbacks, and let farmers know when we see an issue that needs attention, like a tile drain blowout, for example. Applying only enough phosphorus for the following crop rather than the next several crops in rotation can also make a difference. And today we'll hear about soil sampling for P, and pH to make sure that we get the best results with precision ag techniques. Next slide. So ag retailers are making a big difference. For example, our annual survey shows large increases in variable rate application. Here in the Sandusky River watershed, increasing from 17% of acres serviced when our project started in 2011 to a peak of 70% in 2016, declining just slightly in 2017. In 2015, we secured funding for ag retailers to offer a discount on variable rate to farmers in the Sandusky watershed who had not used it before. And we know that farmers stick with the variable rate and expand it to additional acres after they've had their first experience. We've expanded this project to 3 additional watersheds in Northwest Ohio this past year and had over 40 ag retailers participate. So using published estimates, our acres of VRT alone here represent more than 1 million pounds of phosphorus kept from leaving cropland in the watershed. We need to track and report these improvements we're making so that regulators and the public are aware of our voluntary efforts using the power of the marketplace to drive improvements. You'll hear more from Julia about some additional tools and resources we have for you to use as we work together to achieve these goals. So thanks, Julia. I'll turn it back over to you.
Thank you, Tom. As Tom mentioned, we do have some free resources available on our website, partnershipfarm.org. On the left is our continually updated agronomist handbook, available free for download. The handbook includes algal bloom updates, trends in customer product and service adoption, and fact sheets that you can use to provide to grower customers to increase awareness of products and services that reduce nutrient runoff. Our phosphorus loss reduction wallet cards are on the right, which can be ordered for free on our website as well. These are a great conversation starter with your grower customers and can also serve as handouts in meetings. To date, we have distributed more than 25,000 wallet cards. Our next webinar will occur late July or early August and will discuss the pros and cons of fall applied nitrogen. Emails will be sent out soon for registration. You can influence future topics by filling out our evaluation form after the webinar. We also invite you to follow us on Facebook and Twitter for PARM updates and industry news. Now we'll get the presentation started with Dr. Antonio Mallarino, Professor of Agronomy and Nutrient Management Research at Iowa State University.
Good morning. I assume you can hear me. You can see the slide in your screens.
Yep, everything sounds and looks good.
Okay, thank you very much. First of all, I'd like to say that I appreciate very much this opportunity to share my views, to a large audience, in several states. And I'm hoping that this is useful for most of you at least. Then I'd like to say two disclaimers. One is that, of course, I have 25 years experience about these issues in Iowa, and I think I have a large data set and I can justify some things I will say, but of course I have not worked in other states, but I assume that most of the things will apply to the Corn Belt states. So, and the other is that I'm one of those that hate speaking to a computer screen. I like the eye contact with the audience. So if I am kind of boring in this presentation, I apologize, but I'm trying my best. Okay, soil sampling is one of the most common and important source of error in soil testing. If the sample that we are taking doesn't represent the field or the area that we sample, then we will be building a castle on thin air in terms of recommendations, applications, and management. And everybody is in a hurry. Seems that all of us have to do more with less resources and less time. So I've seen many times, that the sampling is done really in a hurry without thinking much about the implications of a bad sampling. We have several issues. One is sampling depth consistency. This is important because we have a stratified P and K and even pH in most fields, not just in no-till. The timing can be an issue for some things. For example, drought can affect pH and potassium levels mainly. If you are sampling after the drought in the fall, most likely these values will be lower. If you wait to take samples after a rain, then they may be more normal or what they should be. We also have issues with recycling, mainly for potassium. We have lots of data showing that if it is dry and you go and sample behind the combine in the fall, then much of the potassium can be still in the residue. Was not recycled into the soil. But we are talking today mainly about the spatial variability and sampling, because that's by far the most important issue, I think, that we should talk about. And this relates to the number of composite samples per field or area sampled, and the number of cores per composite sample. We have now all these site-specific management tools and ideas and technologies and precision ag, which is very important, I think, and useful, because I think that soil sampling and testing is one of the diagnostics tools that really matches well with the concept of site-specific management. Essentially, with these technologies, what we do is describe, georeference, and account for variation in soil type, soil test, yield, and other soil or crop measurements. We use diagnostic tools like soil testing, remote sensing, tissue testing, things like that, information, and equipment that allows for managing field sections in different ways. This was, we knew for 500 years that we have different situations, different conditions in different parts of fields, but it was tough to do something about it in an economic way. Then we have GPS devices, yield monitors, variable rate technology, aerial satellites, images, etc., that we can use, in order to measure things and then do something about it in an effective way. So when we talk about nutrient spatial variability, we need to understand that often we try to simplify things. For example, the causes of the variability are important and the patterns of variability. And this may not be the same for different nutrients. For example, organic matter, usually the variability is due to natural causes with a few exceptions. pH, we have a combination of both. We have parent materials, and the soils that have naturally different pH, but also we do liming all the time. So we are creating variability. For P and K, at this stage, mainly in the Corn Belt, the variability is explained mainly due to management because of residual effect of fertilizers and manure, especially manure fields, long histories of fertilization, and then removal variation over the field due to yield levels, different yield levels in fields where there are different yield potentials. Now, the problem is that the variability patterns differ among these nutrients. But of course, we measure all in the same sample, okay? And often, even this is important for the temporal dimension. You see, we don't need to measure too often organic matter. We're not gonna see changes, in 4 or 5 years, things like that. But we may see changes year to year, for example, in P and K. So that's what I said, that this is a complex situation, and we try to simplify too much, but then we have to live with the consequences. Now, the most common sampling approach is the sampling by soil type that people talk about, sampling by soil type and topography. The basis for this, and this is the oldest, most universities have been recommending this system for decades, is that soil formation factors may influence nutrient levels. We have the effects of mineralogy, of the parent materials, chemical properties, texture, etc. Then the topography, the landscape forms, also influences the soil profile development, water dynamics, erosion, over the long term, and then also leaching and organic matter accumulation. In addition to all that, soil physical properties may influence yield potential, yield, and secondarily, or because of this, nutrient removal. So it makes sense that when we have a large field, that we are not going to just take a bunch of samples, on course in one spot or arbitrarily, because if we have these different soil map units, different slope, and so forth, then we should do what is called a stratified sample. We should, separate these areas that potentially could have different levels to do a better job. This is an example from our Iowa sampling publication, where there are things like it is most universities where you are supposed to sample individual fields, but then within the fields, if there was some different management, you should take different samples. And if you have different soils, then you sample different soils. And in some areas, for example, like this, if there is even one soil map unit, but it's kind of large, and you can take, more than one sample. And most states recommend one sample every 10 to 15 acres, even if the zoning by these soil map units determine that some sampling areas could be large. But what's the problem? In the early 90s, people started doing some grid sampling and trying to see what is the variability at a smaller scale. This is a field that I sampled many years ago, and in central Iowa. It's about 40 acres, and you can see here that the soil map unit. I don't know. I'm assuming you can see the cursor in the screen. The soil map unit says that it's essentially one map unit, not just one soil series. It's one map unit because the map unit considers the erosion phase and the slope phase. However, we did a very dense, grid sampling there, and you can see that it's all kind of variability. For example, soil phosphorus seems that the variability is kind of random, and was 16 to 86 ppm, that the optimum in Iowa for the Bray method is 16 to 20. And then potassium and then pH seems that there are some zones, you see this, the northeast part of the field have higher pH, than the other parts. Here in nitrate and organic matter, obviously this is one field, but seems that there was something there in the past because there are no straight lines in nature, and you can see here how there is more nitrate and more organic matter in the western part of the field. So because of this, then this grid soil sampling started to explode in the early 90s, mid-90s. And of course, the issue is that the more samples one take, the better. And then we take more samples with grid sampling, be if it is 2.5 acres, which is the most common, or 4.4 acres, or 5 acres, or something like that. Now, grid sampling assumes that nutrient difference are not due only to soil types or topography. And if there were an effect of the soil types and the topography because of the dense sampling, that would account for this anyway. And the other good thing, of grid sampling is that you have a bunch of points so that you can use all this kind of software to extrapolate, and then you can use that for variable rate technology, that is common, and can be used. Now, what is that we have been finding in Iowa, at least? We have been sampling field scale, over the last 20 years, more than 25,000 samples in different ways. And to look at the variability patterns of pK, pH, and organic matter. And what we found is that the amount and the patterns of the variability vary across fields and nutrients. And but also that there is very high small scale variability, not only where P or K are banded, but even when it's broadcast fertilization is used, we find very high variation. That the most frustrating thing is that because of this variation in the variability patterns across fields, no sampling plan can be expected to be the best across all fields and nutrients. Okay. And then dense grid sampling seems the safest because we are having a dense sampling, we are covering all corners, and so it should be better. That's what we find. Now, I'd like to say a few things, that relates to this sampling by soil map units. We need to be careful because, in my opinion, is that some people are expecting too much or asking too much for some of these beautiful digitized soil survey maps that we have. So we need to remember that these maps were done, usually using lots of interpolation on a scale of 12 to 15,000 to 1. And we know, that some of the soils or some of the boundaries that we see in these maps may be there, maybe 200 feet away, or may not be there. Some of my colleagues in soil survey get a bit angry when I say these things, but it's important. I believe people need to be careful about it. This is an example. We did this in many fields. This is about 50 acres. On the left, we have the soil survey map digitized. We have this series, these slope base faces and so forth. But then some of the here Iowa State soil survey people were there for a week doing a very dense mapping, and they found that this is supposed to be the real soil map on the right. So from the fertility point of view, well, if it is a Marshall or a Marshall B2, there's not much difference, but we need to be careful with it. I'm not criticizing the digitized soil maps. I'm saying that some people are asking too much. And then no wonder that sometimes we see when we follow some of these for sampling, things may not add much. Okay, the other thing is that in order to see what we get, we did in many fields. I'm just showing an example of 3 fields. Here on the left, we have the scales. This is phosphorus, for very low to very high in field 1, field 2, field 3. And we sampled these fields here across the top in 4 different ways: a half-acre grid point sampling, a large point sampling where we went to a larger area, and then what we call cell sampling, when instead of sampling a point of about 100 feet by 100 feet, we just walk all over the cells, taking soil sample, taking cores, and then putting a composite sample, and then the sampling by soil type. So you can see, so this in the top is all the same field, sampled in different ways. And the second is the same, and the third is the same. So these things are very worrisome, because of course nobody can afford a half-acre grid point sampling, but this is the closest things to the true distribution of nutrients that we have there. And when we go to some of these, you know, that are less dense, or the sampling by soil type, for example, here we are saying that most of the field tested optimum. And here, when we sample large cells, we say that it's very high or high, when actually this is what's going on. Now, in this field, things are not that bad. The majority of the field is low, and that is shown by the sampling by soil type. And in this other field, the north portion of the fields tends to be very high, and that shows in most maps. But you see, we need to know this. That's what is happening in many fields. So we need to be very careful, you know. This is pH, and I'm not gonna spend time, you know, in the same field. It's not as bad as for P and K, you know, but this happens. So the other thing we have done is to look at the impact of the small scale variation and what different trends we see in the fields. So what we did in this case, we are showing potassium, and we did transects of about 500 feet. And each of these points is a composite of 10 cores. So we took every 10 feet, we walked 10 feet, then we took 10 cores in around a 5-6 feet area, and we put into a bag, and then we walked 10 feet and again. And then I plot this, you know, across the rows for 2 fields and along the rows. And the interesting things that we see are these trends here, these wavy trends in many cases. These things, I mean, so many wavy ups and downs like here in such a systematic way don't happen in nature. Usually in some soils of the south could happen, but not here. So if you look at this, the distance between these peaks and valleys is about 60, 70 feet. So this is obvious that this was created by the broadcast fertilization with the floaters, you know. So that's another thing, you know. Some people believe that we are doing high precision work by sampling and using GPS, but may not be looking, you know, how the application is being made. This shows now we took samples in the same transects, but also took them every 6 inches and analyzed the core independently. So, I mean, in some fields, you know, it's clear, it's no major problem like this that is generally low. But in some fields, you know, with intermediate soil test, and look here, this field with manure, we have that the variation over 25 feet is about of the same degree that we see over 500 feet, although these are composite of 10 cores and these are single cores. This is a real world, okay? This is what happened. So this is important when we are talking about sampling by any method, but also by grid sampling. The most common grid sampling method that people are using is what I call the systematic grid point sampling. And what I did here, this is a hypothetical thing, I just overlaid some points over these polygons with colors are soil map units, okay? So what people do, they just plan, you know, they go a systematic sampling. They just go to some points, you know, within the cells, and then just take a sample from this area and do not change this point. They are just systematically aligned. So this can be a problem with in some fields where I show that we have these systematic variations due mostly to fertilization, because all these points may be riding on a wave, may give erroneous results that do not really represent the area. In the early days of grid sampling, people used to do what I call the cell sampling, which is actually walking all over the cell, taking cores, but for a variety of reasons, everybody's in a hurry. Most now are doing the point sampling, as I will say later. Probably that's a good idea. Here is what I believe should be the best grid sampling, which is essentially the sampling points over the field. They are not aligned. Now, in this case, they're random. Okay, they are not aligned. But for example, here we have some points that are in the middle of the intersection of supposedly two different soil map units. So people could move this point, to one or the other. So we are not taking something that is in between two soil map units. Now, the problem is this is easy to do if the sampler has the information before of the soil types and plan the grid sampling in this way. But then in the field, of course, it's much easier just to go with a four-wheeler along a line and not be wandering, all over the field. So I understand, but this is the ideal, I think. So because of these issues, the issues we have with the sampling by soil type, because people saw that we may need to do some more dense sampling, then we started, about in the late 90s, to talk about this management zone sampling. Management zone sampling, essentially, what it tries to do is to improve the sampling by soil type and providing an alternative to the more costly and usually blind, because it's systematic, grid sampling. So the idea is to delineate sampling areas based on many information layers, not just soil map units, but also maybe topography, elevation, yield, electrical conductivity, solar canopy images, and things like that. So now the issue with this sampling method, which should be better than the sampling by soil type because it's considering other information, is that assumes that these factors are the cause or are related to different nutrient availability or crop needs, okay? So it's the same assumption that we have with the sampling by soil type. Now, what we have been seeing is that often this is not the case most of the time for P and K, and sometimes for pH. So this is the idea, okay? We got all these layers information that we may get. Not everybody has all this information. They can start with one or two, and they can add more levels. It can be done just by hand, printing maps on the floor of a room, or can be done with some software that is out there, but this is the idea. What happens, and some people tell me, is that the more layers you include, you may end up, with a zone sampling that you have as many samples as if you were doing a 2.5 acre grid sampling, and it is true. So this has to be considered. We can use many things. For example, here is an aerial photo of corn early from about V1 to V7, V6, and you can see some clear, and I overlaid the soil map units on top of it. So you can check, that not only that the corn growth may give you an idea of what's going on, which may be related to nutrient levels or not. Most likely this is water excess or deficiency. But you also can look, how these lines for the soil map units, well, as I said, sometimes they may be okay, but sometimes may be off, and they may be exactly as they are shown there or may not be. In areas of the Western Corn Belt, where we have some high pH calcareous soils in our fields, that's the case in Western Iowa, Northern Iowa, Western Minnesota, and the Dakotas. We have these issues that we may have, a variation in pH from 5.5 to 8, over 100 feet or 50 feet. We have these spots of calcareous soils. This is a problem for grid sampling, because you can make it one core with an area that is pH 8, you know, and mix with 10 cores that are acid, and you screw up that sample. But also it's a problem for the management zone sampling, you know, because most of the things don't show in the soil super map. Calcareous spots about 1 acre or less do not show. So some things that we can use something that is bad for something good. For example, this is we can use the iron chlorosis deficiency in soybean. That we can get an aerial image, just color. We don't need a sophisticated image. And then they can tell you this here in the photo on the lower part, these yellow spots, those are calcareous soils. And actually, in the top, we have this cornfield the following year. You can see that even you can see those calcareous spots in the corn, probably because some was nitrogen volatilization of nitrogen leaching in low areas of the field and so forth. So what it means that there are many of these information layers that could apply in some situations or in others. And in particular, in the Western Corn Belt for that has calcareous soils, even with grid sampling, I think that doing once in a while an aerial image, trying to identify where the calcareous spots are, I think is useful. Now, of course, somebody can walk over a field, you know, when the beans are V5, V6, you know, and you can put flags that we go with a GPS and you can mark those. And then when you are planning the grid sampling or the zone sampling, you can put this in there, and then you can decide, okay, should I sample, or if they are small areas, just ignore them, you know, and do something. But this gives you more information about the fields, which again needs time. So we did some research years ago with a PhD student, because of course the more sample one takes, the better. But we wanted to create to look at what sampling method is better in order to identify the probability of a different response to fertilization, to P and K within a field. So we created this efficacy index. We have strip trials without in many fields, and then we measure yield and yield response, and we split the yield map in different sections. And then before that, we sample very dense grids, 0.3 to 0.5 acres. And we say, okay, this should be the best, okay, to describe really what's going on in the field. So we gave that a 100. That's the most efficient. Then we did a 2.5 acre grid sampling, a zone sampling, and a sampling by soil type. These are the efficiencies that we found. So what we have seen in the fields, and this type of information is telling me that for P and K at least, a grid sampling, a well-done grid sampling is better than zone sampling on sampling by soil type, because of the reasons I said before. This difference especially changes a lot depending on the field, okay, as I said. But usually the grid sampling is up. So what I'm saying out there is that, in my opinion, the clear thing with this is that we should move out from the simple and easy and all sampling by soil type. Okay, we should try to do either grid sampling or try to do zone sampling. That's what we see. And the reason why this sampling, zone sampling sometimes don't work is here. Here is an example for two fields. In field 1, this is the distribution of areas of the field that were very low, or optimal. Okay, so we have about 12% very low, 60% low, and optimal about 25%. So when we do a sample by the soil series, we got exactly the same value. And when we do the zone samplings, we got about the same value anyway. And this in field 2, we have a different distribution. We have largest areas very low. And then we see that in this case, there is some relationship with the soil series. And with elevation soils, with elevation zones, we can pick up some of this variability. But as I said before, in most cases, not always, the safe bet is the grid sampling. Now, Again, I like to insist on this because in different areas, the results could be slightly different. See, why in Iowa, at least, soil sampling for P&K is not better? It's because of the long histories of fertilization and manure application. See, soil testing was low, soil test P&K was low in these soils, and after 100 years, fertilization, this is masking any difference that soil types or topography could have had. The within field yield variation has to be very large and consistent over time in order to influence soil P&K levels through removal. See, in north central Iowa, for example, it's typical that the difference in yield in corn is not consistent year after year. But this year we have excess rainfall, so corn is drowned in many low areas. There will be no yield or very little, but in dry years, that you have the highest yield in the field. So what I believe is that, and I have been not in other states, but I have been in some areas for Argentina, Uruguay, and South America, the results for zone sampling should be better in fields or regions with either more contrasting soil types, where really the soil properties are so different that creates large difference within the field, or when there are shorter fertilization histories. Now, I said a couple of times a well-done grid sampling. The main thing that I mean by that is this that I put here. One is that I know some people are doing grid sampling about 10 acres. I don't think that shouldn't be done. If you're going to do a grid sampling 10 acres or more, you better do a zone sampling. The grid sampling should be less than 4 to 5 acres, and I believe that 2.5 acres is better. Of course, a denser grid sampling, it will be even better, but then nobody can afford that. Then this is a question that I get often. What is better, the point sampling or the cell sampling? So just take a point of about 100 by 100 feet, within a cell, or just walk all over the cell taking soil sample. Well, it's not consistent. It's different. It depends on the field. Now, in general, what I see, people don't want to walk all over a cell. It takes more time to take samples. And then because of the small scale variability, really what may happen in some fields that even if you had 2.5 acres and you walk taking 10, 15 cores all over the cell, when you come 2 years later or 4 years later, really you are sampling a different population because of the spatial variability in a small scale. Doing a point sampling, then at least you are sampling year after year or every 2, every 4 years, you are sampling the same spot, and that could be more useful when studying trends over time. The other issue is that we should take at least 10 to 12 cores per composite sample. It doesn't matter the grid size. People believe because they're doing grid sampling, they can just get away with taking 4 or 5 cores around the four-wheeler. I mean, that's not the case. I mean, you take 3, 4 cores, 5 cores, you will have a beautiful map that may not really represent much what's in the field. And I say that because this is just an example. I went to many fields where I sampled about an acre or two, taking single cores and in all different ways. And what we see is this general trend. See, here I have what we call the confidence interval using some statistical formulas, the confidence interval for the measurements in single cores. And then we see that when we took 5 cores, really the error is extremely high. You see, if this field, for example, this portion of field have 19 ppm, which is in the optimum for phosphorus in Iowa. And see, you take 5 cores, and that number that you measure with a composite with 5 cores could be plus minus 6 ppm. I mean, now, on the other hand, if you take 20, 30, 40 cores, then that doesn't change much. But what I tell people is that they should look at this shape, you see. This is always like this, going down exponentially. It may be less pronounced, or it may be more pronounced depending on the variability, but it's never something like this, So what this means that a couple of cores difference here in this low range makes a difference. And it's no wonder that for decades we have been saying you need to take about 15 cores. Well, I say at least 10, 15 cores, you know, even in grid sampling. I know it takes time. I know there are issues, but as I said before, you are doing this, and then there will be lots of money invested on this. Now, recently we started having these automated sampling things. I'm not doing any propaganda. I just know they are out there. Some people are using them. So taking more cores, if co-ops get these machines or farmers get together, of course, I don't think a farmer can afford buying these samplers, but consultants could. So then the issue of the number of cores may be alleviated a bit at least. I want to say something about the sampling depth. It's just one slide, but I think it's important because, again, people are sampling soils in a hurry, and I don't think they're paying attention. And different people take soil samples in different years. Then some things don't match, and they blame the lab, when in general, the problem most likely is the spatial variability or inconsistent sampling depth. You see, most fields in the Corn Belt are stratified for P and K, not just in no-till and pasture, because even with the chisel plow and field cultivation, you know, we have stratification. So it is important that we standardize the sampling depth. And I'm not going to get into the issue of what depth should be sampled. That's another topic. Most states of the United States have found that there is no advantage of sampling for P and K shallow, 2-3 inches. That's the case in Iowa. But a key issue is that the sampling depth that you guys do should be the same that was used for the soil test calibration. See, in Iowa, for example, all the calibration research that we have a lot, we have calibrated all the soil sampling, the soil test methods since the 50s for a 6-inch depth. The same things in Minnesota, Nebraska, Missouri, Wisconsin. I believe that Illinois, they still sample 8 inches for some reason. So, I mean, I'm not saying that the sampling depth should be within 6.1 and 5.9 inches, but we should be sampling 6 inches and not 7 or 8 or 4 or 5. And then some people in no-till that sample shallower, well, we don't have the interpretation. And then, of course, the soil test will be higher, so the interpretations do not apply. For lime in Iowa, it's a different story, because with sampling for P and K is an index. For lime requirement, we need to know what is the volume of soils that we want to change pH or that will change. So in Iowa, because liming of no-till and pastures don't change pH more than about 3 inches, then we have a different depth sampling. We say 6 inches with tillage and 2-3 inches in no-till or pasture. Or if they sample 6 inches for no-till and pasture, you need to be careful that who makes the recommendation, because you need to divide the recommended lime by half. Otherwise, we put in too much lime. So consistency in the sampling depth across fields and years is crucial, is important. The issue of the spatial and temporal assessment is a tricky one, and I don't have a straight answer. Those that are doing grid sampling and a good grid sampling are paying attention to the spatial variability, which is right. But most of them are sampling every 4 years. This is the old thing, you know, sampling every 4 years that is there. With grid sampling, we take more samples and describe nutrient availability better. But of course, the costs are higher. Some sampling seems to be of lower cost because we take fewer samples. But in some fields, we may have as many samples as with grid sampling. And also, we need office and computer time and knowledge to do the zone sampling, which is also expensive. So I'm not sure really if the zone sampling really is cheaper more affordable than a 2.5 acre grid sampling. Maybe in some situations, not in others. So what I'm seeing, given all the issues we have, given that we have these temporal effects, mainly in potassium and pH, people investing lots of money in hybrids, in equipment, in precision ag, and all the stuff, but then we are doing soil sampling every 4 years. I believe that considering all of the above and considering water quality, especially for phosphorus, I think that sampling every 2 years for the corn soybean rotation is not a heresy anymore. I think that this could be a good idea. It accounts for the spatial variability and also for some of the temporal variability, and provides useful long-term trends, because guys can look, you can have more years that you can look at the trends. And when you have this annoying temporal effect, for example, mostly in pH and potassium, by looking at the long-term trends, you can decide, or if there is a major lab error, which is possible, then you can decide, the heck with this thing, I will go for the trend, and in soil test and yields and removal. Would it pay? Probably not always. With the prices we are having these days in the crops, I'm not sure. So the only thing I'm saying is that people are paying lots of attention about the spatial variability and what to do about it, but forget about the temporal assessment. And of course, what to do depends on the situation. If somebody has been doing sampling for a long time and the fields are mostly at an optimum, then it's not much need to a frequent soil sampling. But if it is a new field or you're doing major changes, I don't think it's a good idea to wait 4 years in order to see what is happening. Then, of course, some people have high testing all over the place. They're applying P and K that they don't need. Of course, then why bother sampling every 2 years? That's another thing. Okay, so with all this, then, as I said before, the beauty of grid sampling or of a zone sampling well done, with many zones, is that we can use variable rate. And it is proved that this works. Years ago, we were in doubts. Now it works for PK and lime, at least for nitrogen. There are some issues. I'm not talking about that. So the issue is, what is the sampling method to use, and the increased cost. Now, the cost of variable rate used to be expensive in the early years, in the middle 90s. Now, it really is not much of a difference, between using variable rate or just using a uniform application, all over the field. So what I want to show here is that it's not just what I showed before. The variability in fields is large, and I am convinced that variable rate tagged with a good grid sampling is a good practice to do, not just for the crops, but also in the case of phosphorus for water quality, because we avoid having high testing areas, and too high at least in many fields. This is just an example of the many fields that we went, and this is the percent area that we found areas testing very low, medium, high, or very high. I put medium. In Iowa, it's actually optimum, because some states call it medium here. So you can see that most fields have many large variation, in terms of the soil. This was done with a dense grid sampling, by the way. So we have this variability in different fields. And then by doing these strip trials, we did we evaluated the response in each of those fields in these different areas that tested high or low or very high before. So this shows, this is the actual response, is the yield increase in bushels. I think this was corn. So we can see that soil testing is not perfect, but it works. We have the larger increases in the very low testing areas and lower increases in the high testing areas. So it's not just an artifact of the soil sampling and the testing that shows this variation, this variability. It is real, and the response is real. So we can use good soil sampling and variable rate technology in order to get better management, you know. Now, well, this is for potassium, is the same thing. We did all these types of research. We worked on about 70 trials over the years working with co-ops that we did this type of trial. We look at uniform rate and the variable rate. And what we found from this is that it's important to know the variable rate not always increases yield. A switch to variable rate does not always increase yields. See, we need to be careful because especially you consultants, if you are, or co-ops, if they're trying to sell this technology to farmers, I mean, you need to be aware really what may happen. Well, in some cases, we don't have a yield increase. Why? Well, because most farmers are maintaining soil test levels at or above the optimum levels. See, they are very, in almost every field, no matter how testing in average, there are some spot low, but this may be very small. So, and then even with variable rate, you cannot measure them well, or when you are, I mean, applying, then there is no yield difference, you know, because what they should do is not to apply so much PRK in some of those soils. Okay, in some other cases, there is extremely high small scale variability. This is especially high when there is bonding, you see. And this is one of the reasons that I know for water quality, people are talking about bonding, you know, but in Iowa, we don't find that bonding is really much efficient for P and K, for corn and soybean. We have 30 years research on that. And the bonding, so sulfur bonding, yeah, may reduce phosphorus loss, you know, but not necessarily as much as some people believe. And then when you're applying high rates of P and K bonding, then you know the soil sampling is a nightmare, and the only alternative there is to take a trillion cores and more samples, you know, because there is no way, even with precision application and RTK GPS, it's difficult to know really what to do in those cases. The other reason is that in most of our expenses and in most of our states, the rates that we recommend for low testing soils in general, are rates designed to maximize yields. For example, in Iowa, the rates that we recommend for low testing soils are not to get maximum economic yield, because we believe that if the farmer will make a mistake, even with unsafe land tenure, in low testing soil, they should put the fertilizers needed, and it's better to err to put a bit more than not less. Okay, not necessarily build up all at once, but be sure that the P and the K are not short there. So when we go do these trials, you know, and we follow our recommendations, well, we are already applying a bit more P and K than needed, you know, in very low, in soils that test very low. So then when we go with the variable rate, yeah, we may apply a few pounds more, you know, but really it doesn't make a difference. So you need to be aware about this. What I believe, and I have some examples here. This is the example that everybody expects, that we get the variable rate yielding more than the uniform rate, you know, in soils that test low or very low. But most often what we find is this, there is no some different. So we need to be careful about it. So in my opinion, given that more than half of the fields in the Corn Belt test high or very high in P. I'm convinced of that. In Iowa, we know that. The main advantage of switching to variable rate may not be increased yield, but it may be to reduce the amount applied, which of course some companies may not like, but farmers should, because they will be applying less fertilizer that they don't need, or apply less P, reduce the field areas that test high or very high, and that should improve water quality, because there should be less phosphorus runoff or loss with tile drainage from those fields. Now that the savings of material, of course, depend on the amount, the degree of variability, and what is the overall leverage in the field. This is an average for all these trials that we did, but it varies very much, as you can see here. So it depends. But in general, assuming that many fields have a test high or very high or are all over the place high, you know, the main thing for switching to variable rate is that the farmer will see a savings in product application, and we should see a benefit in water quality. That's what I believe. Now, it may be areas where there is large areas testing low, you know, and then in that case, of course, there would be a yield increase. So nothing is perfect in life, but variable rate is not perfect, but it works. This is an example for a field where we took samples, 3 cycles of corn soybean rotation using variable rate, and what we show here is the areas of the field that initially tested very low, optimum, or high, and then the soil test speed changed after these 6 years by not applying anything, by applying an uniform rate all over the field, is the gray bars, or by using variable rate, which is the black bar. So it is very clear that, again, it's not perfect, and it may not happen at once or 2 applications, but over time, variable rate reduces the soil test variability in the field. For example, here we see the higher change up of soil P when we use variable rate. When it is optimum, we try to maintain, we didn't change much. And then, of course, if we don't apply, we get a decrease. So again, this is a good technology. Now we need to be careful. We need to sell it, quote, for the good reasons. And people should understand some of the pitfalls and when it could be work better than or worse. So I believe also that with bad prices like we may have now is more justification for good sampling and variable rate application. Farmers tend to think the other way around. Oh, I'm not going to spend money. Well, they need to, because by doing this, they really have the best estimate possible. Where are the low testing sites in the field? And then, as I tell them, don't cut below the SU recommendation rates. I mean, we should not have, because there is a high probability of response. Now, some people are applying build-up rates, not just for 2 years, as we recommend in Iowa, but for several years. So then with bad prices, why we will build up, apply more P or K that is needed when the prices are bad? So people should be careful with that. And then in optimum areas, maintain based on removal. That's what most states recommend. And then in high testing areas, do not apply. This is one of the beauties of grid sampling when we have many samples over a field, because some farmers or consultants may be nervous. If you have just 2, 3 samples over a field and say, you know, it may be right or not, I just will apply some PRK just in case. Well, if you have 10, 12, 15, 18 samples per field, you really can see if some areas are consistently high. And then they may have the stomach to decide don't apply in that area. Okay, I want to emphasize this is not directly related to the sampling topic, but I think it's important. This is information for Iowa, okay? And this shows for 3 different price ratios, the profits, the net returns from fertilization, okay? This is for P and K. This is our good prices on the left, kind of intermediate price on the center, and bad prices on the right. See, this is real. These are not modeled. This is real data. And these are in red are the Iowa interpretations, okay? It is very clear that soil testing is not perfect, but it's good. You can see that when the soil tests are very low or low, it doesn't matter the price ratio. There is a high probability of responses anyway. However, on the other hand, when the soil test is very high or very high, it doesn't matter price ratios. There are losses to investment, not necessarily losses to the crop, but losses to investment in fertilizer here. And then, of course, there is all this gray area when the soil tests are around optimum. So people should think about this. And that's why I believe that grid sampling of well done and variable rate is important, because they can make more money. And by doing this with phosphorus, they can They should. It's tough to get direct information about the impact of variable rate on water quality. But if we are doing over time, if we have this good sampling method and we see that we start to reduce the high testing areas in the fields, we should improve water quality. So I think that there is better management with a well-done grid sampling with variable rate, but we need to be careful about how it is used and how we can expect, especially in fields that test all over the way high. It is very important. I didn't get into the issue of recommendations, to use good recommendations, because people are applying P and K where they should not be applying. And a good technology used with wrong recommendations will not work. It will give the appearance that it's working, but will not work. And with that, I think that I am at about the time planned to stop. I'm not sure if there are questions. I forgot where I should see these questions, so maybe Julia can help with us in this respect.
Yes, thank you, Dr. Mallarino. We do have time for Q&A. I will moderate the questions so that you can answer them. Attendees, please enter your questions into the question box on your screen if you have any. So the first question is, if you have multi-year yield data, can one create an indexed yield map that, regardless of crop, can show historical yield variations and then help to identify soil variations?
Yes, that is possible. In fact, in some of our research, we've done that. The problem is that many people don't have historical yield monitor maps, or if they have them, some people say you need to be a PhD in order to go to a computer, and put all this, and come up with an index. Yes. There are some areas where that is useful. For example, southern Iowa, western Iowa have these fields with big slopes and so forth. There tends to be a consistency in terms of yield in the different parts of the field. But if you go, for example, for central Iowa and this Canistales, Clarion, Webster Association, it's a nightmare, because really, even if you work over 4, 5, 6 years, it's just the variability in yields in these spots, wet spots, it's horrible. But yes, and actually that's what I recommend for using in variable rate. Most people are using variable rate only based on soil test values. They do not include yield for the removal because it's difficult. And some are doing it with the last yield map. For example, they are sampling next fall, and then they use this corn, whatever, or soybean yield map, and then they go according to that. I think that's wrong. They should use at least the yield maps, for the last 4, 5, 6 years or something, and then go vary the removal according to that, not necessarily for one yield map. Now, this is easy to say. It's more difficult to do it.
Thank you. The next question is there any research being done involving groundbreaking technologies or sensors that will completely change the way we collect soil data?
I believe there is and have been, although people are still arguing about that, is for nitrogen sensing. There are some issues with the nitrogen because of the it's not perfect the technique, and then the impact of side dress, and so most people don't want to side dress nitrogen and so forth. In the case of P and K, I don't see it too soon. I know there are some people working on sensors, but at this point, I have not seen that too soon. In terms of pH, there are a couple of companies that offer these samplers that they do pH on the go, and that they seem to be good. And as long as they are calibrated for a farm or for a field, they are good. So yes, we can send a robot to Mars, point a nose to a rock, and tell us the total composition, but we don't have that can tell us how much is available for P and K yet.
All right, thank you. Next question is, do you have an opinion on differences and advantages and disadvantages between using satellite data versus yield monitor data to select soil sampling points?
In my opinion, it's not one or the other. Ideally, should use both. And actually, I believe that aerial images with drones or airplanes that have higher resolution could be better than some satellites. I know there are some companies that offer high resolution for a price. See, in my opinion, both are good. See, some of my students that have worked in precision ag say, well, you know, if the yield map doesn't tell that there is some variation, then it's not worth to use other things. That's what they say. But I believe that it is useful to have both things. And I gave that example for soybean, the iron chlorosis as an index to identify calcareous soils. So I would try to use both, and then with that, see. But remember what I said. Those things assume that they should be related to nutrient availability, and may or may not.
Okay, thank you. And next question is, any recommendation for interpolate the soil maps based on the measured soil values? I see there is sometimes high, small scale variability. How shall we interpolate the soil map for the whole field in this case?
That's a good question. In my opinion, the most important thing by far is the decision about the grid cell size and if it is point or cell sampling, and I already discussed that. The second issue is that there are many interpolation methods, and really I have not seen much of a difference, practical difference between the interpolation methods. But the thing that happened for all of them is that a systematic sampling is not good at all for interpolation. When you get all these points all aligned in both directions, those things tend to create these hot spots, you know, bull eyes, things like that. So the best thing for me in interpolation is not the method of how fine you do the interpolation or not, but the density of the sampling, the reliability of the sampling, and try to avoid a systematic sampling.
Okay, and next question is, to what extent do soil sampling / VRT fees make up the revenue in cases where less P is applied?
If I understand right the question, that's the $1 million question. I believe that, of course, it's not economical to do something every year. So, but I believe that most farmers are applying every 2 years for corn and soybean, the rate. And I have data that as long as the pounds are there is a good thing. And so that's what I believe, that given all the considerations, given the economics, given the variability, given the temporal variability, and given the water quality concern, especially for phosphorus, I believe that a well-done grid sampling every 2 years should be an effective practice. Can I guarantee that that will pay with corn at $3.50 or soybean at $9? I can't. So what I tell people is, I think we should try to sample more often. That's the most I can say. See, you need to consider also that if you look back in time, the cost of soil sampling and the cost of soil testing has not changed much over the years. Yeah, have changed, increased a bit. So, I mean, when all this thing of the sampling every 4 years came up, I mean, it was 20, 30 years ago, 40 years ago, you see. Now, in relative terms, and given all the cost of production and inputs and good hybrids and combines and tractors and all that stuff, the cost of soil testing really is not much. People, I tell you, farmers don't doubt spending $10, $15 per acre sometimes on snake oil. Some of these things, that most people know don't work. But then when they come to spend $10, $15 per acre in good soil sampling, then they don't want to do it. So that's my view.
Okay, thank you, Dr. Mallarino. In the interest of time, I'd like to wrap up the Q&A. I want to thank Dr. Mallarino for joining us today. We really appreciate you taking the time to share your work.
Thank you very much for this opportunity, and I hope it was useful or make some of you think about things. Bye.
At this time, I want to recognize our participating egg retailers. If you are an egg retailer in either the Great Lakes Basin or Mississippi River Basin that is interested in participating with PARM to benefit your business and surrounding water quality, please contact our outreach coordinator at caitlin@partnershipfarm.org. Finally, I'd like to acknowledge our funders, collaborators, and members that made this webinar possible. In particular, the support of La Crosse Seed, the Great Lakes Protection Fund, the McKnight Foundation, Clean Lakes Alliance, and the National Fish and Wildlife Foundation. We've also been enrolling corporate members to support our partnership, so we'd like to highlight our members: the Andersons, a gold member, and silver members, Gert Egg Services LLC and Crop Production Services. Their contribution helped make this webinar possible and helps promote the strides that egg retailers like you are making to reduce nutrient impairments. If you are interested in becoming a member and receiving the additional benefits included, please visit our website, partnershipfarm.org, to fill out our online form. As we wrap up, please remember to look for the email in a few days with a webinar evaluation, webinar recording, and a link to submit your CCA credentials to earn the 1.5 CCA CEUs, only if you have not already done so during registration. I want to thank you all again for joining us today, and I hope you join us again for our next webinar next month.